Okie dokie, I'm going to try to go through these rather quickly. Your homeworks for last night. So we're looking at a question about two particles. This is from a Form B test, so this one's extremely more difficult than I think you would expect a normal position velocity to be about, but I just want to review some important concepts, so it's a good something to walk through. So you have two particles. They're two different position functions, okay? And this is only from 0 to 6. So that's all you know. So for A, it says find all times t when r is moving to the right. So that's a question about its velocity, right? So whenever its velocity is positive, which would be taking the derivative, right? Establishing critical numbers, so it stops at 1 and 3. And then creating a sign chart to show the direction of the velocity. So if I test points in r prime at 1/2, at 2, and at 4, I'm going to go ahead and get plus minus plus by testing them right in here. Okay? And so that means r is moving to the right over 0 to 1 and 3 to 6. Okay? And that's because r prime is positive. So I know this looks crossed out, but this is correct. Okay, part B. Find all times when the two particles are traveling in opposite directions. So we have already an analysis about what direction r prime is traveling in. So basically you have to figure out where p prime is traveling right or left as well. So this is an attempt to do p prime, right? So this is the derivative of this guy, right, is composite. So it's going to be negative sine because of cosine times 2. So I have a negative 2 for my leading number here. And then I've got the pi fourths because I have to multiply by the derivative of pi fourths t. Okay, so that's here and it stays here. So the hardest part to me about this is setting this equal to 0. Right? And so my work over here kind of shows how I would do that, right? When we have a composite function like this, we have to let kind of a substitution happen where u or a, depending on what you guys did last year in pre-calc, you let u equal pi fourths t. We want that to be equal to 0, right? So we would figure out, we want to know, when this overall thing is equal to 0. So I'm going to take that guy and I want 0 and pi, because those are the regular places where sine is 0 within the interval 0 to 6. So I set those u values equal to the pi fourths t in order to get the t values. So those actually end up being whole numbers, 0 and 4, right, when you solve and multiply by 4 over pi. Okay? So those would go on your list. 2 pi is outside of the interval, so we don't include this one. So 0 and 4... right? 0 is an endpoint, 4 is in the middle, is the number I would put on here, and then I have to check the sign of all this mess, right? So we're going to go ahead and pick maybe 1 would be easy to plug in because then it'd just be sine of pi fourths, and then 5, sine of 5 pi fourths would be easy, so you have to figure out if this is positive or negative, and then this sign change will make it the opposite, right? So this is negative to positive, okay? Once you get that, you have to kind of compare these two things together. So when I put r prime's information, right, together with p prime's information, I put the 1, the 3, the 4, all the critical numbers on here, and then I fill in with as many pluses and minuses as it takes until I can see the places where they are opposite. So it looks like 0 to 1, they're opposite, and 3 to 4, they are opposite, right? And so that's what I'm going to present as my answer, okay? You don't even have to justify. So if you can get that, oh my gosh, great for you. To me, part B is the hardest, right? Part C you can get without doing part B, okay, so don't give up. It just asks to find the acceleration at time 3. So you do have to take the derivative, right, of p prime to get p double prime. So it is involving the chain rule again to get this guy here. So negative pi squared over 8 cosine of 3 pi fourths. When you plug in 3, turns out that whole thing is negative. Right? Oh, wait, cosine of 3 pi fourths. That's negative, right? So when you multiply it by this negative entity, you get positive for all of that, right? And so you have to compare the sign of p double prime at 3 and the sign of p single prime at 3, which was negative, looking back up here. So because they're opposing, right, they're in opposite directions, that means that the particle is slowing down. That's velocity and acceleration are in direct opposition, okay? If they were in the same direction, then you would say it's speeding up. And then D, I would have no idea how to do. I'll just be frank with you. So if you're going to find the average distance I mean, this phrase average to me, it indicates average value. So I would go ahead and do 1 over b minus a, and then this is the difference between their distances, right? So that's calculating that difference, and then the absolute value kind of takes away the fact that p or r is ahead of the other, and it kind of ignores the sign of the difference between them. So quite frankly, I would lose this point. It's 2 points. I would lose this if I was taking this test. But if you can understand that, props to you. The next one is, oh, weird, an accumulator function. Shocker. So this is more of the same. You have to be improving, okay? I don't mind like 1 or 2 errors on this, but you have to be, having a decent guess at 2 of the 4 parts on this particular assignment, okay? So g of 2, it looks like from 1 to 2 is what we're going to do for part A. We're going to count up the area from 1 to 2. It's this little tiny triangle that is below the x-axis. So that's why the answer is negative here, right? Negative 1/4 is the area of that. Its base is 1 unit, but its height is only 1/2. So 1/2, 1 times 2. Or, sorry, 1/2, 1 times 1/2 is 1/4. It's below the x-axis, so it's negative. Okay? For part B, g of negative 2, I think this is going to be our final answer here. We're going from 1 to negative 2, and then we're going to, we have to invert that and make it opposite. And then we're going to have to find the area from negative 2 to 1, which I'll outline all of this junk, right? Below the x-axis, above the x-axis. Count all that up, subtract the area of the semicircle from the area of this shape, and then once you do all that, then you indeed have to make it opposite of that. So that total of here and here is actually 4 minus pi halves. Because these limits are switched, you have to answer pi halves minus 4. Okay? Part B, g prime of negative 3 is 2, just reading that from the graph. And then g double prime is 1, because that's the slope of the graph, the slope of that segment here at negative 3, right? So remember, this is also g prime, so hopefully you labeled that earlier and you didn't have to state that again. Okay? I'll let you read through C and D. I think you guys are getting better and better at these. Especially D, you should be getting correct. C, you might have to double check all this stuff here. So maybe just go ahead and pause the screen so that you can check your work on those 2 things. Okie dokie.